Okay, so what we're looking at is StormCAD inside of Autodesk Civil3D 2019, which is the version of Civil3D I had. And I've opened a file called sample1. You can see it's a DWG, but automatically StormCAD creates another set of files with the same name, so sample1. And these are StormCAD specific, so SQLi, DWH, HTSW, which is where all the hydraulics and hydrology information is stored. So you can see that if I click on an element, so we can look at this here. For example, this is a pipe, and you can see the start node, which is the diameter, material, etc. So all that information is being stored in the SQLite database. Now, from this interface, you can compute. So I have actually a couple of scenarios in this file. One is an analysis scenario. So I'm going to make that one my current scenario, and I'll compute it. And all that information that gets either input, like diameter, for example, or calculated results like flow, velocity, etc., are in the database, but they can be extracted to use as annotation, or you can actually go to the flex tables. Let me see, for example, since we're looking at conduits, you can see the white data is what we enter, the yellow is what gets calculated. You can see length, slope, diameter, velocity, flow, etc. One of the most typical means of reviewing results is through profiles. So I'm going to look at a couple of profiles that I have already generated. And they are, let me just open it up here. So for the scenario that I just ran, this is the hydraulic rate line, water level. Red line is the energy rate line. This is the profile. The white here is the pipe itself. You can view this profile two ways. This is the standard profile, but I can also open that profile in what we called the engineering view. And when I open the engineering profile, and let me maximize this a little bit, you can see that there's a default information here, but you can modify that annotation for any element. Okay, and if you like the profile and you want to include it in your drawing, you can do export to drawing. I'm going to minimize this. I'm going to say that I'll place it like here, and it gets automatically inserted there. So that's the analysis scenario. If you look at the other scenario, it's the design scenario, which is based on some design alternatives. So if we go to our alternatives, we can see where are my alternatives? Here's my design alternative. This is again what you can customize. So these are the defaults that come with the software, but you can create your own seed file with its particular constraint for the pipes. So you can control velocity, cover, slope, partful design number, barrels, and section size. For the structures, you can decide how they match, if there's going to be a forced offset, or if you want to allow or not drop structures. Also decide which of the structures you want to design for their elevation. And because we're doing stormwater, you can also design the inlets. So basically size them for you, given a spread and gutter depth limitation, if you so choose. Okay, so when you run a design, I'm going to go back to my scenario for design and compute that really quick. Of course, it's going to redesign my system based on that criteria, so it will create new physical characteristics. I'm going to say yes. I had already designed it, so I don't think there's going to be very many changes. And so what it's doing, it's trying to figure out the right diameter and invert structure configurations that meet all my criteria. And if they're all able to meet the criteria, you're going to get a green line. Here we say the maximum spread is exceeded from those parameters that I input at a couple of inlets, so I can either zoom to that particular location, and let's close that up. So we can see here that those design constraints are being violated. Let me close out of this. Okay, and the reason for that is that this is an in-sag inlet. It's not, doesn't have a gutter that takes the excess water away from it. So you can try modifying that, or yeah, maybe placing other inlets before that much water accumulates there or something. You can see here that I have, if I go to StormCAD view, there's something that we have called element symbology. And the element symbology allows you to do the annotations and color coding. I have already color coded my elements here based on the diameter. So if I open this up, you can see that I have just set the standard values, but these are smaller diameters, obviously, than what's on the main transmission line. So you can do that, but not only diameter, you can do any property that's either input or calculated. All right, so I just wanted you to get an idea of what it feels like to work inside of Civil 3D.